All right, so we are still working with the exponential function, and we've been working with exponential growth, but now exponential decay is when something is decreasing left to right exponentially, exponential decay. All right, our formula is still the same. So it is still exponential function, a times b to the power of x. And a is still our y-intercept. If we're dealing with our graph, in story problems, it's still our starting amount. And now b, instead of our growth factor, we're looking at our decay factor. So it's still like that rate at which something is decreasing. So for growth, b had to be greater than 1. For decay, b has to be in between 0 and 1. So it's greater than 0, but it's less than 1. So we're dealing with numbers like 0.2, 0.5, 3/4. Those types of numbers, if that's your b value, then it will decay or decrease. All right, so now I'm going to start a table of values, and we can see if we can see the pattern and write an equation. All right, so 0, 800, and we're going to go 1, 2, and 3. All right, so now 250, 12.5. All right, so we want to know, what are we multiplying by to get to the next number? Well, if numbers are getting smaller, we're multiplying by a fraction. So just remember, we can divide backwards to figure out what we're multiplying by forwards. So 200 divided by 800, that's going to simplify down to 1/4, or 0.25. So we are, whoops, that's supposed to be a 4. So multiplying by 1/4, so let's continue that. Well, first, let's continue the x. Those are just going up by 1, that's easy, 4 and 5. All right, now 12.5 times 1/4 is 3.125. If we multiply that by 1/4, we'll have 0.78125. So numbers are decreasing rather quickly. All right, so let's think about equation now. The number that matches up with 0 is a, and then the decay factor is b. So y equals 800 times 1/4 to the power of x. All right, so let's graph exponential decay. We're going to do this function, y equals 4 times 1/2 to the power of x. Let's make an xy table. And remember, these numbers can get really, really small quickly, can get really, really big quickly. So we want to start, let's just -1, 0, and 1. All right, so 4 times 1/2 to the power of -1. 4 times 1/2 to the power of 0. 4 times 1/2 to the power of 1. All right, well, negative exponent to the power of that fraction. Real quick, I would just want to go through this. So 4 1/2 to the power of -1. Well, that would mean 4 times, let's see, that exponent goes to both of those, 1 to the power of -1 over 2 to the power of -1. And now negative exponents, remember we can move them and make them positive. So I have 4, and then I'll have 2 to the first over 1 to the first Well, that's just 2, and 4 times 2 is 8. So you can plug these in your calculator and go a little faster, but I just wanted you to see how you can do it by hand. All right, so this equals 8. Anything to the power of 0 is 1, and 1 times 4 is 4. And then here, this is 1/2 times 4 is 2. And you can continue the pattern, see how they're just getting cut in half. So we could even go very easily, cut it in half. 1, we could go 3, 1/2. All right, so let's plot these points. -1 all the way up to 8. 0, 4. 1, 2. 2, 1, 3.5. And remember, they will get smaller and smaller forever, but never actually hit 0 or go below 0. Got my arrows, and just a reminder of that word asymptote, which is right there. All right, domain and range. It's actually the same as exponential growth. It's going forever in these directions, so it's hitting all x values, so all real numbers. And then the range, it's only hitting numbers where y is greater than 0. All right, here's a story problem. Suppose the acreage of forest, so of a forest, is decreasing by 2% per year because of development. So there are currently 4,500,000 acres of forest. Determine the amount of forest land after each of the following years. So we'll do 10 years and 20 years. So our starting amount, 4,500,000, and then the 2% will relate to the B, but there's a trick. When we were doing growth, we had to do 1 plus the percent. But if we want something to decrease, we'll do 1 minus 2%. So to write my function, A is 4,500,000. And B is 1 minus 2% as a decimal is 0.02. So that, you could also, one easy way to think of this is 100% minus 2% is 98%, which is 0.98. So either way, all right, so my equation, y equals 4,500,000 times 0.98 to the power of x. All right, so now you guys have done these questions with growth, so why don't you pause the video, plug in 10 for x, see what you get, plug in 20 for x, see what you get, come back and check your answers. So in 10 years, the acres will decrease down to 3,676,000, and in 20 years, it decreases 3,004,000. All right, another type of question involving exponential decay is called half-life. So there are certain substances that they decay, carbon being something that decays. And there's different types of carbons, and we'll talk about different types in class. So how long does it take for a certain substance to cut in half? They all have different time lengths. So this one, it says the carbon, or the half-life of carbon-11. That 11 is just part of this type of carbon. There's different types of carbons. So the half-life of carbon is 20 minutes. So this carbon-11, it means the substance cuts in half every 20 minutes. So a sample of carbon, so carbon-11 has 25 MCI. So 25, that's our starting amount, and this is a unit of measurement. So how much of this carbon-11 is in the sample 1 hour after the original sample is measured? All right, so there's lots to think about here. We have our original amount A. What's our B? The getting cut in half is our B. So Y equals, we're going to start with 25 MCI of carbon-11, and it's getting cut in half every 20 minutes. So how many 20 minutes exists in 1 hour? 20, 40, 60, 3. So it will get cut in half 3 times. So 25 times 1/2 to the power of 3, or you can just cut 25 in half 3 times. It equals, in an hour, there will only be 3.125 MCI left of carbon-11. All right, there is your lesson on exponential decay. Good luck.